how to find the directrix of a parabola. Alright, so just in case you didn't know, the directrix of a parabola is a line that is the same distance from the vertex as it is from the focus, but it's on the other side of the parabola. Okay? You might call it the outside of the parabola, and then the focus is usually on the inside of the parabola. Alright, so let's take a look. Notice I said vertex and focus, which is why we need to find the vertex first. So, in this case, we're given this equation. We need to find the vertex. Luckily, it's already in vertex form, and here's the general form here, okay, where h is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. So, we just simply take this value, here's that h, we put it right here, and we put the k value, and we put it right here. Notice, though, that the sign is opposite, okay? So since this is a -8 here, we have a +8 for the vertex, x value, okay? If this was a +8 here, then we would have a -8 here, okay? A lot of students get tricked on that. Don't forget about that. But for the y value, we just keep it with the same sign, okay? Yeah, this happens quite a bit in many equations when we have something inside of parentheses, okay? So that's just something to remember as you learn more math. All right, so now that we have the vertex, we go to step 2, and we need to calculate the focus. And we can calculate the focus by using the vertex. So here's our equation here. Also put it down here in my handy dandy scroll. All right, notice the h is just the same, so the x value stays the same here. That's pretty simple. But in order to find the y value of the focus, we need to have k, which was the y value of our vertex, as well as this a value. Okay, and if you forget, a is the coefficient in the vertex form of the parabola, so that would be here. So that's how I put the -3 here. That's how I put the 5 right here. And then we simplify it, and we get 8 comma 5 plus 1 over -12. So that becomes 8 and 4, 11 twelfths. 4 and 11 twelfths. Okay, so now we got that. Finally, we can find the directrix. Okay? So remember, the vertex, like I said before, is actually the midpoint between the focus and the directrix. So we can simply use the midpoint formula to find the vertex here. Okay? That's why I said midpoint / vertex. Okay? And in this case, since our parabola is going up and down, okay, it says the y equals, we only actually care about the y value when we're calculating this, because the x value will always be the same, right? So, our vertex and our focus, they're both the same. Okay, so we can just ignore that for now and only worry about the y values. Okay, so our y value for the vertex was 5. Okay, then our y value for the focus here. All right, so notice this. Hopefully this looks familiar as a midpoint formula, or you could also say the average, right? So we're here, I substituted. Now we simply just need to solve for this directrix value here. So I multiply both sides by 2, I get 10 equals this. Then I subtract both sides by 4 and 11 twelfths. And I get my directrix is 5 and 1/12. Now, if you were listening very carefully, I said the directrix is a line. So most teachers, I don't think will be happy with this. You should write it in equation form. So in this case, our directrix is y equals 5 and 1/12. You can find it if your parabola is horizontal, but that's a little bit different. We'll have to go over that in another video. So here is our final form. Directrix is y equals 5 and 1/12, which is a horizontal line, which is, like I said, the same distance from the vertex as the focus is, but on the outside of the parabola. And that completes our problem.